All right, so in our last lesson, we talked about how we have these two sets of numbers, right? We have the real number system, and those are the numbers that we're used to. And then we have the imaginary number system, right? And real numbers are numbers that do not have an I, where the I part is equal to zero. Remember, we talked about how, uh, you know, 5 or square root of 7, like those are all real numbers. Imaginary numbers are numbers that have I with them. So, for example, 5i or 2 minus 3i are both examples of imaginary numbers. They're both part of that bigger number system called complex numbers. Okay. And remember, a complex number is any number that can be written in this form, a plus bi. So real numbers are complex numbers. It's just that the b part, the imaginary part, is equal to 0. So it doesn't have the I part to it. Imaginary numbers have the I, so the b is not equal to 0. For example, in this case, the b would be 5. In this case, the b would be a negative 3. So we have this big complex number system. What we're going to practice today is solving quadratics. But now when we solve quadratics, it's going to say, solve it using the complex number system. And what that means is now, like before, if I got the square root of a negative, I would always say that there was no real solution, which is true. But now we know that square root of a negative is actually an imaginary number. So there is a solution. It's just an imaginary number solution. So we're going to practice finding those. So let me show you an example. X squared minus 6x equals 16. I want to solve this. It says use the quadratic formula. Again, I don't really care how you solve these on the assignment. This is completely up to you. This one, right, I can't factor. If you try taking the factors of negative 16 to add up to be a negative 6, it is, actually, maybe it does work. Let's try it really quick. Let's see if we can solve by factoring. Like x, and let's see, minus 8 plus 2, like I times those, get negative 16, they add up to be negative 6. So my answer is going to be 8 and negative 2. If I use the quadratic formula, right, I would go x equals negative b. B is a negative 6, so positive 6 plus or minus square root of something all over 2 times a. A is 1. Let's figure out what goes inside of there. That's the b squared, so 6 squared minus 4 times a times c. So that's 36. Minus 4 times 1 is a minus 4 times a negative 16 is a plus. Let's see, 4 times 16 is 40, 24, 64. I add those together. Hey, square root of 100, 10. 6 plus 10 is 16 over 2. 6 minus 10 would be negative 4 over 2. So I get the same answer. So it doesn't matter if you're right. It doesn't matter if we solve by factoring or solve using the quadratic formula. We ought to end up with the same answer there. Okay, let's try this next one. Let's just use, this one looks harder to factor. I think it actually does factor, but if it's going to factor, it's going to be a little bit harder because of the 4 out in front. So let's just use the quadratic formula. There's my a, b, and c. So I'm going to go c is equal to negative 20 plus or minus square root of something all over 2 times 4. Let's figure out what that, this is actually, by the way, I don't think I ever gave you this name, but really quick, the quadratic formula, we talked about this yesterday on the last lesson. This part right here is what determines what kind of answer we're going to get, and it actually has a name. It's called the discriminant. So what we're going to do is let's find that discriminant that goes right there. So that's the b squared, 20 squared, minus 4 times a times c. Let's see, 20 squared is 400. 4 times 25 is 100 times 4 is 400. End up with 400 minus 400, which is 0. So this is that case where we only get one solution, right? I end up with negative 20 over 8. Plus or minus 0, but plus or minus 0 goes away. Simplify that. You can divide it both by 2, actually by 4. So it'd be negative 5 halves. So this particular quadratic only has one solution. And again, that's determined by that discriminant right there. Okay, let's do this last problem. And this is the one that is going to be a little bit different from what we've done before. So again, quadratic formula, I'm going to go x equals negative b, negative 7, plus or minus square root of, and we'll do that part off to the side, 2 times a, 2 times 3 is 6. Let's find our discriminant, 7 squared minus 4 times 3 times 5. So that would be 49. 4 times 3 is 12, times 5 is 60. 49 minus 60 is a negative 11. All right, so in the past, we would just stop right there and say, hey, no real solution. And that is true. This is not a real number solution because you cannot take a real number. Square root of negative 11 does not equal a real number. But it does equal an imaginary number. So the difference on this assignment is it will say solve in the complex number system. All that means is it's okay to get an I. So my job is just to simplify this answer as far as I can take it. So let's see what we can do. Square root of negative 11, we did this on yesterday's assignment. We can break it apart to be square root of negative 1 times the square root of 11. That comes out to be I. Square root of 11 does not simplify. So we're just going to leave it as a square root of 11. So I have x equals negative 7 plus or minus I squared of 11 all over 6. That's really as far as we can go. I can't simplify the square root of 11. There's not a factor on top that I can take out that will reduce with the bottom. So really that's as far as I can go. Now remember, that's two answers. I have negative 7 plus or minus I squared of 11 over 6. Oh, shoot, I was going to write that as two separate answers, sorry. So let's do it the first time. With negative 7 plus I squared of 11 over 6. And my second answer would be negative 7 minus I squared of 11 over 6. Those are my two solutions. Now, if I wanted to write those as complex numbers look like this. I could split that fraction apart and write it as being negative 7 plus, this is like, I'm going to take the square root of 11 and 6, sorry, negative 7 over 6 plus square root of 11 over 6i. These two things are the same thing. Right? I just split it apart. Negative 7 over 6 plus I squared of 11 over 6. And I just dropped the I off to the side. So remember that form we said that A plus BI? Well, A is the negative 7, 6, and B would be the square root of 11 over 6. Same thing here. We could take this one and split it apart. We could write it as being negative 7 over 6 minus square root of 11 over 6i. On your assignment, I believe they're going to write it this way, which is fine, but just be aware if I split it apart, I could write that in that form of that A plus BI. It can be written in that form. Okay, that really is the only thing that's different is you're going to practice solving quadratics now that have solutions that are imaginary. So if we get square root of a negative, we're not just going to stop and say no solution. We're actually going to solve it. Let's just do one or two more just so you can see it. I'm going to save that A, but let's go ahead and solve B right here. So if I saw this problem to start with, I would check first just to see if I could factor it, because that looks pretty easy to factor. So are there factors of 5 that add up to be 4? There aren't. Now, if that were a minus 5, it would actually work, but it isn't. Okay, so let's use the quadratic formula. So x equals negative b, negative 4, plus or minus square root of b squared. I'm going to do that up. Oh, we'll save that for a second. 2 times 1. There's a 1 there. And let's do the b squared, 4 squared, minus 4 times a times c. Well, that ends up being 16 minus 20. 16 minus 20 is a negative 4. That goes inside of there. Okay, so right away we can see this is not going to have real solutions. It's going to have imaginary solutions because I have the square root of a negative. Let's simplify the square root of negative 4. That would be I squared of positive 4. Square root of positive 4 is 2. Okay, so it comes out to be 2i. So now I have negative 4 plus or minus 2i all over 2. Okay, last thing is we can take that, there's a factor on top that cancels with the factor on the bottom, right? I can factor a 2 out of the top. If I factor a 2 out, I just have that. And now those 2's will just reduce. So simplified all the way, it comes out to be negative 2 plus or minus negative 2 plus or minus I. Okay. So my two solutions, negative 2 plus I and negative 2 minus I. That's what it comes out to. Let's do this C right here. So again, quadratic formula. X equals negative b, so positive 4 plus or minus my all over 2 times 5 is 10. Right, this is the discriminant. Let's find it. So b squared, so negative 4 squared minus 4 times a times c. Well, that would be 16 minus 20. Oh, we've got the same thing, almost the same thing. That's negative 4. We just did the square root of negative 4, so this comes out to be 4 plus or minus 2i, right? That's what we got when we simplified square root of negative 4 all over 10. Now again, there's a common factor of 2 you can take out at the top. 2 plus or minus I, take a 2 out. The bottom is 10 is 2 times 5, and now we have a factor of 2 we can reduce. So your, plus or minus. So your final answer, again, I think on the assignment, if I'm remembering correctly, it writes it this way. Just be aware, if you wanted to, think of that as being a 1i right there. Sorry, 1i instead of I. So if you wanted to, you could split that apart and say that's 2/5 plus or minus 1/5 I. Like these two things are the same thing. You can take that I, you can split the fraction up, 2 over 5 plus or minus 1 over 5, and put the I off to the side. So either one of these two is okay when you go through and solve that. Hey, this A, you could use a quadratic formula. It's like having x squared plus 0x plus 9. So A is 1, B is 0, and C is 9. And you could use a quadratic formula. It's a lot easier, though, if we recognize I can just, this is one I can just solve using the square root method. Like I can just get x squared by itself, just minus the 9 over. So x squared equals negative 9. Take the square root of both sides. So x equals, don't forget the plus or minus, square root of negative 9. Well, let's simplify that. I'm going to come down here out of the way. Square root of negative 1 times the square root of 9. That part's I, that part's 3. So I end up with x is equal to plus or minus 3i. And there's my two solutions. So you can see how, again, square roots of negatives, that's just going to make it so we end up with i's in the answer, okay, or imaginary solutions. Okay, something that's a little bit different, zeros of a function. We've talked about this before. Just as a reminder, the zeros of and this is something we went through in the last chapter, but zeros of a function mean, okay, it's what you can plug in for x to make the function equal to 0. So to make the function equal to 0. Okay, so what can I plug in for x to make a function equal to 0? So I'm going to come up here, like the way we did this is I want to make the function or the y equal to 0. So really all I'm doing is putting 0 in for y. So now I just have to, really I'm solving a quadratic equation. That's all we're doing. Same thing we've already been doing. So we can solve this however we want. Remember, factoring is a really easy way to solve it if it works. So are there factors of 12 that add up to be 7? And this one actually does work, right? We can factor this. It'd be x and x and 3 and 4, right? My factors 3 and 4. When I times them, I get 12. When I add them, I get 7. So x plus 3 and x plus 4. Okay, what would make that one equal to 0? That would be negative 3, and that would be negative 4. So those are my zeros of the function. Now, something we talked about, we may or may not remember, is those zeros, as long as they're real numbers, they're actually also x-intercepts, right? Because if I'm on the x-axis, y equals 0, right? My function is equal to 0. So that means this one crosses, I don't know exactly what the graph looks like, but I know it crosses there and it crosses there. The axis symmetry would be halfway between there, and we could find the vertex and draw a sketch of it. So there's a connection between the x-intercepts and the zeros of the function. So again, think of zeros. What do I put in for x, right? What do I put in for x to make the function equal to 0? So set the function equal to 0, make y 0, and solve that either by factoring or a quadratic formula or the square root method, any one of those ways we've done it. And those are the zeros of the function. If they're real numbers, like -3 and -4, they come out to be real numbers, that means that they're also the x-intercepts. Okay, when we go through and find those. So let's do this one right here. So it says find the zeros of the function. All right, so we're going to, again, I want to find out what makes the function equal to 0. So plug 0 in for the function. So 0 equals 4x squared plus 20. I want to find out what would I plug in for x to make that true. In other words, I want to solve this quadratic equation. Well, to solve it, I have to get x by itself. So I'm going to minus the 20. This one, because there's only an x squared, I can solve this one using the square root method. I can get x squared equals a number and take the square root of both sides. You could also use the quadratic formula. That's just a lot more work. So I'm going to get that x squared by itself. I'm going to minus the 20 over. -20 equals 4x squared. Divide by 4. So x squared equals -5. And now I'm just going to take the square root of both sides. So x equals plus or minus, okay, and square root of -5. We can break it apart to be square root of -1 times the square root of 5. Square root of -1 is I. So I end up with plus or minus I squared of 5. So the zeros of the function are negative I squared of 5 and positive I squared of 5. Now, what that means is if you get imaginary zeros, what that means is that this function does not have x-intercepts. So if your x-intercepts come out to be real numbers, or your zeros come out to be real numbers, that means they're also x-intercepts. If your zeros come out to be imaginary numbers, that means that there are no x-intercepts. So the question was, what are the zeros? Those are my zeros. If it asked me to find the x-intercept, right, I would say that there are no x-intercepts, and I know that because I got imaginary numbers right there. By the way, we can tell this on this graph. Like, I'm not going to draw a sketch of it, but just to think about it, this is really just shifted up 20 and has a vertical stretch of 4. So let's say this is 5, 10, 15, 20. It's up here, has a vertical stretch of 4. It's going to be really steep. That parabola, something like that, there are no x-intercepts. But it still has zeros. So long story short, x-intercepts are always zeros of the function. But the function can have zeros that are not x-intercepts. The only time that happens is if they are imaginary, like that problem right there. Why don't you guys go ahead and try? I want to do one of these. So let's take this problem number 6 right here. Pause the video, and I want you to find the zeros of that function. Okay, so hopefully you found that. Just double check it. So again, think zeros of the function mean I want the function to equal 0. I want y to equal 0. So 0 equals x squared minus 6x plus 10. Okay, so I've got to solve that quadratic. This might be worth trying to factor. Right? What are the factors of 10? I want them to add up to be -6. You could do -1 and -10, -2 and -5. That adds up to be -7, but not -6. So it looks like this one, I can't solve by factoring. Let's use the quadratic formula. So A is 1, B is -6, and C is 10. So let's plug it in our formula. It's x equals -b. I already have a -6, so +6, plus or minus square root of my discriminant we'll find in a second, all over 2 times 1. Okay, let's find our discriminant. I do the -b squared, or sorry, not -b, just b squared. So -6 squared minus 4 times a times c. That would be 36 minus 40, which is -4. We've got a lot of -4s in there. Okay, so this, what that means, whoops, sorry about that. What that means is I'm going to get an imaginary zeros. So this means it doesn't have x-intercept, but it still has zeros. So let's find those. Square root of -4, you can break apart to be the square root of -1 times, just fix that. Square root of -1 times square root of 4. That would be I, and that would be 2. So I end up with 6 plus or minus 2I over 2. You can factor a 2 out of the top. That'd be 3 plus or minus I over 2. You can reduce those 2's. So the two zeros, this is what I can plug in for x to make the function equal to 0. It'd be 3 plus I and 3 minus I. Okay, it'd be the two zeros of the functions. What that also means is there's no x-intercepts, right? Because I got imaginary zeros. So today's practice isn't going to be very different from what you've already done. You're going to be solving quadratic equations. That's what you're going to be doing. Probably mostly using the quadratic formula, but you can use any method as long as it works. The only difference is, instead of getting always real solutions, on a lot of these you're going to get imaginary solutions. You're going to be practicing when you have i's in the problem. But other than that, again, we're just solving quadratic equations, and that's all we're doing. All right, good luck.